Hi guys, welcome to this maths class on trigonometric ratios. And I promise to make it really easy for you. Trigonometry is a very interesting topic with lots of applications. It's also used a lot in physics also. So very important topic that you guys should know. And I'm going to make it crystal clear. So let's begin. Before we get started, just a quick reminder, do check out the other courses on our website if you haven't taken them already. We have our Android app also, where we have all these physics, chemistry, biology, maths courses. We also have artificial intelligence, Java and Python coding, and do share it out with your friends. And make sure you have subscribed to our YouTube channel, Manocha Academy. Before we dive into trigonometry, let's see why we're studying this topic. What's its use? Trigonometry has very interesting uses like, do you guys recognize this building? This is Burj Khalifa, right? And if we want to measure the height of Burj Khalifa without going to the top and, dropping a very, very long measuring tape, how do we do that? In trigonometry, you can actually be standing on the ground, measuring a certain angle, and you can very accurately give the height of Burj Khalifa. In fact, trigonometry is hugely used in architecture to make estimates of heights, distances, and all of that. How about if you're on this bridge, right? And you want to measure the width of this bridge. Now, you can't cross the river, right? That becomes difficult. So again, you could use some trigonometry, measure some angles, and you could estimate the width of the river. So trigonometry has very interesting applications, and those are called as heights and distances in your topic. We're not going to go into that today. We have video on that, or I'll be teaching that later. Today, we're going to understand what is these trigonometric ratios, what are they, so with that we can easily apply them. So let's look at that. All of you guys know what is a right angle triangle. First, let's start with that. Right angle triangle, very simple. A triangle which has a 90-degree angle. Okay, so this is a right angle triangle because it has a 90-degree angle. And we know that, what do we know about a right angle triangle? If you know two sides, can you find the third side? So let's say I tell you that, hey, this BC is 6 centimeter and let's say AB is 8 centimeters. Can you find the length of the other side AC for me? All of you try without trigonometry. So famous Pythagoras theorem we are going to apply here, right? Because it's a 90-degree angle. So we'll say, okay, this is 6 centimeters, this is 8 centimeters. So this one will be square root of the sum of the square of the other two sides. So 6 square plus 8 square, which is square. If you calculate 36 plus 64, that's going to give me 100. Square root of 100 is 10 centimeters. Or you could have been given the other two sides. You could have been given AB is 6 and let's say BC is 6 centimeter and AC is 10. Find the other side. So whichever two sides are given, you can apply it into this Pythagoras theorem, right? AB square plus BC square is AC square. Basically, the hypotenuse square. Hypotenuse is the largest side, which is opposite to the 90-degree, is equal to the sum of square of the other two sides. Very simple. And that's how you get it. So basically, in a right angle triangle, in summary, if we know two sides, we can easily find the third side using Pythagoras theorem. Now let's look at some important trigonometry terminology. So let's say again, we are dealing with this again in trigonometry, you're dealing with just like Pythagoras with a right angle triangle. So you can see now any of the angles could be right angle, need not always be B. Let's say this angle is 90-degree. Okay. The another angle is usually marked as with this Greek symbol theta. Theta is usually used for angle rather than X or Y. So you'll see this 90 and a theta. Now, in this triangle, you can see angle B is your 90-degree. Angle C, we have marked as theta. Now, there is some important terminology about base, perpendicular, and hypotenuse. And it is with respect to this 90 and theta that you have marked. Okay. So, if you have marked this 90 and theta, what is going to be the hypotenuse? That you know from Pythagoras, the side opposite to the 90-degree. So, everybody agrees that opposite to the 90-degree, this right angle is called the hypotenuse, which I'm going to mark with the letter H. So opposite to 90 degrees hypotenuse, which we mark with the letter H. Then the side which has both the 90-degree and this magical theta that we marked, the side which contains both angles is called the base. Okay. So the side which contains both 90 and the angle theta is called the base, which we are going to represent with B. And so all of you, please draw this diagram and mark this as B here. Note that base is not just because, hey, here it's looking like the base, right? It's at the bottom of the triangle, or this is the base of the triangle. That's not the definition. The important thing to keep in mind, base is not the flat one or the one lying down here. Base is the one that contains 90 and theta. This is a very common mistake. Okay. And what is the perpendicular? The other side, right? So we can say the other side is called the perpendicular, or in another way you can think which is opposite to the theta. Can you see? Which is opposite to the angle theta that we call as the perpendicular. Okay, so I've marked it with P, B, and H here. What does this theta mean here? It's the angle, right? So this, just like this is 90 degree, this could be 40 degree, 50 degree, 60 degree. So please note, theta is nothing magical. It is just a symbol representing the angle, which could be anything like 60, 50, whatever, right? So theta is basically representing the angle here. We could have marked with X, Y, whatever, but trigonometry is famous for theta. Now, why that theta is important? Because all these trigonometric ratios are ratios given with the name, with that sine theta, cos theta, right? So what do they mean? Let's start off with the first ratio. Now, trigonometric ratios are ratios of the sides, and that is why your PBH, right? So we told this is the perpendicular, this is the base here, and that's your hypotenuse. Now, if you take the ratio of the perpendicular, the guy opposite to the theta, and the hypotenuse, the side opposite to the 90 degree, that ratio, perpendicular by hypotenuse, or in this triangle, AB by AC, is known as sine theta. This is not sin theta, it is pronounced as sine theta. So it's not like some sin or crime you're committing, it's called sine theta. Why? Because this ratio depends on this angle theta. Why does it depend? If you think about it, if we say this 90 degrees fixed, all of you agree? We can't change this guy because we're talking about a right angle triangle. You can change the other two angles. So let's say you're changing this angle, right? If you're varying it, do you guys visualize that your P by H is going to change? Can you guys visualize that for me? That if I change this side, the perpendicular length and the hypotenuse length will change. So that's why this ratio will change. So this P by H, perpendicular by hypotenuse, is dependent on theta, the angle. So that's why it's called sine theta. But if this angle theta is fixed, right, then that ratio is fixed, right? So if it's 60 degree angle, no matter what right angle triangle you take, its perpendicular by hypotenuse will be same. Okay, so if you fix that theta, if you make it 60 degree, no matter what right angle triangle you take, how small or big, the ratio of P by H will be fixed. Okay, similarly, cos theta. Cos theta is the ratio, again, of sides, not of angles. It is a ratio of base by hypotenuse. B by H is known as cos theta. Again, if the theta is fixed, the base by the hypotenuse of the triangle, that's the beauty of this trigonometry, that ratio remains same if that angle theta is, let's say, 60 degree, right? So cos theta will always be the same, which means the cos 60 base by hypotenuse ratio is fixed, which is BC by AC for this triangle. Similarly, AB by BC, which is perpendicular by base, is called tan theta. So you have to do some memorization here, right? You have to learn that sine theta is P by H, cos theta is B by H, and tan theta is P by B. So there you can see we have covered all the possible ratios, P by H, B by H, P by B. Now to add to the list, there are 3 more names over here to learn. Okay, what are those? These are not that difficult. These are basically the reciprocal. So you can see cosec theta is 1 by sine theta. What does that mean? If sine theta is P by H, cosec theta is actually H by P, hypotenuse by perpendicular. Similarly, sec theta is reciprocal of cos theta. So it is H by B. Cot theta is reciprocal of tan theta. So it is B by P. Clear? So you can see these guys are basically the reciprocals. So what trigonometry ratios really are, they are ratios of any two sides of the triangle and they are given names. So if you take perpendicular by hypotenuse, you don't call it a P by H ratio, you call it a sine theta. Sounds fancy, right? Basically showing that it depends on that angle theta, sine theta. This ratio is called. B by H is cos theta. P by B is not called P by B ratio, it's called tan theta. Reciprocal part is basically, it is given another name, like rather than calling it 1 by sine theta, you give it a name cosec theta. Rather than calling it 1 by cos theta, you give it a name sec theta. That's all. So what is sec theta? You guys can work it out, right? So cosec theta will be what? Sine theta is P by H. So cosec theta will be H by P. I'm sure you guys can do this. Sec theta is reciprocal of cos theta, B by H. So this will be H by B. Cot theta is reciprocal of tan theta. So that's going to be B by P instead of P by B. Now, one interesting question may come in your mind that is there any relation between this sine theta, cos theta, tan theta? The answer is yes. And the relation is given here. Tan theta is sine theta by cos theta. But you may say that, no, I don't believe this. Let's prove it, right? Is tan theta really sine theta by cos theta? How do you prove in maths? You start with one of the sides, let's say the right hand side. So sine theta we said for this 90-degree triangle, right angle triangle is P by H. So let's put that down. P by H divided by cos theta is base by hypotenuse, B by H. So that we can write it as P by H divided by B by H. If you have fractions, when you're doing division, one simple math trick, change the division to a multiplication and take the reciprocal. So what will you get? P by H multiplied by H by B. Now if you look here, you can cancel H. So what are you left with, guys? P by B. And that was our definition. P by B, by definition, we gave it a name. We said that, hey, that's tan theta. And trigonometry, what is the best way to learn these? I know some of these are difficult to learn. The best way is not to relax on a sofa and look at these, hey, sine theta, cos theta. No. Pick up your pen and paper, write down these ratios, and while writing, speak it out. Sine theta is perpendicular by hypotenuse. Cos theta is base by hypotenuse. That's the best way to learn these. Tan theta is perpendicular by base. Okay. Write them down. You learn it easily. And speak it also. So same way, keep telling yourself, tan theta is sine theta by cos theta. And you can see why. And if you're having confusion about these ratios, like let's say here, these values were 3, 4, and 5. So the ratios will be values, right? This will be a value of 3 by 5. This will be 4 by 5. This will be 3 by 4, right? So if you had certain values here, like perpendicular is 3 centimeters, this was 4 centimeters, by Pythagoras, this is 5. So you will get certain values. That's the whole idea of the ratios. You're getting the trigonometric ratio is the ratio which is defined like this. Now, one very interesting question. Can you see can you spot any difference in this triangle? Anybody can spot a difference between this triangle and what we have been doing earlier? So find the difference between this triangle. So this is very important that you have to look at theta carefully. Now, if theta has gone up over there, one important thing to know that this time who's the hypotenuse? That is very clear. The hypotenuse is opposite to the 90. What is the base? The base is not this one. Don't think, oh, that is like normally we say base of the triangle means, or in construction we say we draw the base. No, not this one. According to trigonometry, base means which contains both 90 and theta. So do you guys agree with me that this time BC is not the base, AB is the base? And who's the perpendicular? And the side opposite to theta, or the third side basically? That is the perpendicular. So this is very, very important. So this time, what is your sine theta? That's why better not to learn it with the sides, because the sides have changed this time, but it is still perpendicular by hypotenuse. So it's BC by AC this time. Cos theta, please see, it is base by hypotenuse, AB by AC. Can you see? AB by AC. And tan theta will be perpendicular by base, which is BC by AB. So this is very, very important that if you are given some tricky question like this, make sure you're looking at the theta, because theta may not be down here. The base could be right here, 90 and theta. Okay. So take care of that. Now, some of you are wondering why these names sine theta, cos theta, what do they mean? So they are abbreviations, right? So it is called sine of theta. Why these names came about, you guys can look at the history. I also don't know that what is the origin of these names. Sine theta, then you have, this is called cosine. Tan theta is called tangent, right? Cosec stands for cosecant. So these are all the, full forms of all these names, right? So sine theta is sine theta, cosine, tangent, cosecant, secant, and cotangent. I know, sounds a lot like Greek to me, right? Theta is also Greek. So all these words are there, but basically you have to write it as 3-letter words, except this cosec theta is the long one. So good question. Can theta be 90 degree? See, if in a right angle triangle, if there is 190, can a second angle be 90? No. So that's a great question. Theta must be less than 90 degree, right? So one important thing, all the thetas that we were looking at here are in the range of, for our right angle triangle, the greater than 0 and less than 90. That's the typical, right? Otherwise, you will not have a triangle. If theta is 0 or if theta is 90, then what about the poor third angle? Okay. Then you can have, powers in trigonometric ratios. So if you take sine theta whole square, one important thing is it is represented as sine squared theta. So this basically means this is nothing but sine theta multiplied by sine theta. In a stylish way, it's written as sine squared theta. So sine squared theta basically means sine theta times sine theta. So in trigonometry, we like all these notations. So it's not written sine theta square, it's written sine square theta. Similarly, cos theta whole cube is written as cos cube theta, which basically means cos theta multiplied by cos theta multiplied by cos theta, because cube means you're multiplying it 3 times. So be aware of these notations. Now, if I tell you sine theta, let's try a question to understand this. Let's say sine theta is given as 12 by 13. Can you guys find the other trigonometric ratios for me? So let's say for this triangle, 90 degree theta, they have given us sine theta. So what you have been given here, sine theta is 12 by 13. So can you guys tell me, does that mean we know that sine theta is basically perpendicular? So if I write it like this, sine theta by definition is perpendicular by hypotenuse of a right angle triangle, and that is 12 by 13. So can I say that this means perpendicular? This is my perpendicular is 12 and my hypotenuse is 13. Is this correct? So please understand the ratio was given, perpendicular by hypotenuse was given 12 by 13. But this doesn't mean this is 12 and 13. It could be 12 centimeter, or even if we forget about the unit, it could have been 12 and 13. It could be 24 and 26. It could be 36 and 39. The ratio is 12 by 13. Do you agree? So mathematically, it would be incorrect to say, hey, that's 12 and 13. Yeah, roughly speaking, you're right. If we want to find the ratio, but it's not really that. So what is it? So we should correctly be doing, we should say, let perpendicular equal to 12k, or you can call it 12x, and hypotenuse is 13k. And this is not YouTube subscribers. This is not 12k is 12,000, 13k is 13,000. No. K means some value like x. So you can call it 12x, 13x. So the whole ratio trick, remember in maths, if you're given ratio 2:3, we said 2x and 3x. Same way here, 12k, 13k. So let's put that down. We know this is 12k, this is 13k. Now we are mathematically correct. Now if I tell you, find the other trigonometric ratios for me, how will you do it? So I know sine theta, that means I need to find cos theta, tan theta, and even the reciprocals if you want, right? So how do we do it? That means we need to find this base, guy. This base we need to find. How can we find it? Again, Mr. Pythagoras always helps us in right angle triangle. So what we can do? We can say perpendicular, the hypotenuse square is perpendicular square plus base square. Hypotenuse is 13k. So we're going to substitute that. 13k whole square. Perpendicular is 12k whole square plus b square. Right? Please check my calculations. So 13 square whole square is 16k, 169k square, 144k square plus b square. So if you guys subtract this, what do you get? 169 minus 144 will give you 25k square is b square. So therefore b is square root of that, which is 5k. This is 5k. Now, once you have got B as 5k, now you can easily find the ratios because in trigonometry, we define these ratios. That's it. You know all your three sides. You put perpendicular by hypotenuse, you put base by hypotenuse, tan theta is perpendicular by base, and the reciprocals also. So it's just a simple substitution. And of course, k will get cancelled. So that's what you guys need to do. Use Pythagoras theorem like we did. And the important thing, so that you're mathematically correct, you take these with k, you solve, we got 5k. Now we can substitute all these and get the ratios. So if you guys go ahead and do that, there's your cos theta, tan theta. Cosec theta is simply the reciprocal of sine theta. So it's going to be 13 by 12. See, reciprocal. Sec theta will be reciprocal of cos theta. So 5 by 13 is 13 by 5. And cot theta is reciprocal of this, right? So can you see there are simple reciprocals here? Reciprocal means just reverse the fraction. That's all. So if a right angle triangle is given and a trigonometric ratio like this is given, you can use Mr. Pythagoras's famous theorem and easily get the remaining ratios. So one important trick you learn, if you know one trigonometric ratio of the right angle triangle, we can find all the other ratios. Let's try this one. If it is given to you, tan A is √3. Find the other ratios of this angle A. So we say other ratios of the, because they're all ratios with respect to the angle. So we don't say ratios of the triangle, because that means basically we are asking you to find sine A, cos A, all related to this angle A. The other angle is 90 degrees. So again, remember it's given to us tan A is √3. So tan A by definition, what was it? It was perpendicular by base, and that is √3. So if this is √3, I can take it as √3 by 1, right? So based on that, so remember this is my base, which contains both the angles. This is perpendicular, opposite to 90 is hypotenuse. We have marked that. So therefore, what I can say? We can say let perpendicular be √3x or √3k. Base is basically k. Remember, don't take it as √3 and 1. And now you need to find the hypotenuse. So hypotenuse will be easy. H square is p square plus b square. So √3 whole square is 3k square plus a k square, 4k square. So hypotenuse is going to be square root of 4k square, 2k. There you go. So we have found the third side. Now based on this, you can find all the ratios. So there you go. We got the same hypotenuse. Now we can easily find sine A. So this time the angle was marked as A, not as theta. That's also fine. So sine A, cos A, all by the definition perpendicular by hypotenuse, base by hypotenuse. You do that and you will get all your ratios. There you go. So please check the solution. Are you getting the same ratios? Please remember theta and A is just a name. It can be sine of x, sine of A, sine of theta. That's just the name for the angle. That's it. Yeah, I wanted you guys to solve this sum, but I think this is pretty easy, right? So now why don't you guys try this next question yourself? 4 tan theta is 3. You need to evaluate 4 sine theta minus cos theta plus 1 divided by 4 sine theta plus cos theta minus 1. Again, to visualize it, it's always good to draw a diagram like this, right? This is the dad trick. Draw a diagram. It always helps you in mathematics, physics, chemistry, whatever you're doing, right? So make sure, and of course, biology is all about diagrams. So go ahead and draw this diagram and see if you guys can work this out yourself, where you have been given 4 tan theta is 3 and you have to find this complicated thing. It looks complicated, but see, again, these are all familiar guys now. Sine theta, cos theta, all trigonometric ratios related to this triangle. My hint would be always mark this, So always mark your perpendicular. The base is containing both the angles, and this is your hypotenuse opposite to the 90. So make sure you mark this PBH. That makes it very easy for you. In the previous question, what did we do? We were given tan A is √3. Tan A by definition is perpendicular by base. That is the definition of tan A. So please write that P by B. Now, if I write P by B is √3, then what is the ratio? √3, but there's no denominator. So I need to write it divided by 1 because finally I want a ratio. Do you agree? So P by B is √3 by 1. So what is each one? Again, we'll use that K trick. √3K B is K, because I know the ratio is root 3 is to 1. We can't say for sure, is it root 3, 1? Is it 2 root 3 and 2? We don't know. So that is why we put this multiplier K. So till here it is clear. So now you know the perpendicular and base. To find all the ratios, you need the third side. Apply Pythagoras theorem. So this is using Pythagoras. What does Pythagoras theorem tell us? For hypotenuse square is perpendicular square plus base square. Now go and apply it over here. What is perpendicular square? Root 3k whole square is what? Root 3 square, 3. K square. B square is k square. Add it up, 3k square plus k square, 4k square. So what will be the hypotenuse? Square root of this. What is square root of 4k square? 2 into k. Because in the next step, all you need to do is, so you know your three sides are root 3k, k and 2k. You have found all the three sides. Now to find all the other ratios, you just have to substitute. By definition, sine A is perpendicular by base. So if you do root 3k by 2k, k and k will cancel. The answer will be root 3 by 2. See here. Better to learn this as sine A is perpendicular by base. Sorry, perpendicular by hypotenuse. Cos A is base by hypotenuse. What is the base here? K. Hypotenuse is 2k. So k by 2k, k will cancel. Half. Now, how do we solve this question? So here you have been given 4 tan theta is 3. So again, you can start off like this. 4 tan theta is 3. That means I can say tan theta, which is 3 by 4. And by definition, I know tan theta is perpendicular by base. So P by B. You guys agree? Again, we can't say it's 3 and 4 for sure. So to be mathematically correct, we need to write P is 3k, B is 4k. So you guys can write it here in the triangle. This is 3k, perpendicular is my 3k, base is 4k. So how much will the hypotenuse be? If you guys apply Pythagoras theorem, square root of 3k whole square, 4k whole square. So you'll get 16k, 9k square, 16k square. If you add it up, you know this is going to be 25k square. So hypotenuse will be 5k. Or if you take the sides as 3 and 4, you know that's going to be 5. Right? Only we add the k because it's a ratio. So once this part is done, it's almost the whole part is done. Now it's just substitution. So now you do sine theta is perpendicular by hypotenuse. What is perpendicular? 3k, that is 5k. So 3k by 5k, 3 by 5. There you go. You found sine theta. You can find cos theta also. Base by hypotenuse. Go and substitute. Base is 4k. Hypotenuse is 5k, 4 by 5. Now go and plug in these values into the question given. There you should do the calculation a little carefully. 4 sine theta minus cos theta. So go and substitute it correctly and see what you're getting. So if you go ahead and do it like this, see, you will get the same thing. We have got sine theta is 3 by 5, cos theta is 4 by 5. Now go and plug it into this big fraction and do your calculations a little carefully. So what will you get? I think you are getting your 12 by 5 minus 4 by 5. So that is 8 by 5 plus 1. And here again 12 by 5 plus 4 by 5. So 16 by 5 minus 1. So if you take the LCM, 8 plus 5 is 13 by 5. 16 minus 5, 11 by 5. So 5 cancel. The final answer is turning out to be 13 by 11. And so that is our final answer here. 4 tan theta is 3. So if I bring it on the other side, it will become 3 divided by 4, right? Look at the question. 4 tan theta is 3. So tan theta is going to be, this is 4 multiplied by tan theta. So if we bring it to the other side, it is 3 divided by 4. And tan theta is perpendicular by base. So P is 3, B is 4. So this is a standard trick in trigonometry. If they give you 4 tan theta is 3, you bring 4 on the other side, it becomes 3 by 4. Simple. Now, do you guys want to learn a magic trick that will solve this question much faster? Is there some trick that we can do here that will help us solve this question faster? So not for this question, guys. We are coming up with another question with a magic trick for this question. So if we have 3 tan theta is 4, we are asked to evaluate this. Now again, you can do that same steps we did last time. You can do tan theta is 4 by 3. Why am I doing this? I'm taking this 3 into tan theta. So I'm taking it to all to one side. So it becomes 4 divided by 3. And tan theta is nothing but perpendicular by base. So you can do that same trick, you draw your 90-degree triangle and all. So you mark your perpendicular, base, hypotenuse. Perpendicular is going to be 4, base is going to be 3, and your hypotenuse will calculate to 5. And once again, you can go and find your sine theta, cos thetas and do all of that. But is there some faster method here? What do you guys think? So this is option 1, right? Where you do all this, you have calculated, then you sit and calculate your sine theta will be what? It will work out to perpendicular by hypotenuse. So that is 4 by 5 in this case. Cos theta works out to be 3 by 5. And then you go ahead and substitute. But let's look at the alternative method here, the faster trick. So what is one smart thing we can do? Let's see. We have been given 3 sine theta plus 2 cos theta. 3 sine theta plus 2 cos theta divided by 3 sine theta minus 2 cos theta. So I have to find this ratio. Now I can multiply the numerator and denominator with the same thing. The ratio doesn't change, the fraction doesn't change. Or I can divide the numerator and denominator with something. The same thing, the fraction won't change. So since I know tan theta, and I also know this special relation that sine theta by cos theta is tan theta, what if I could magically convert these sine theta, cos thetas into tan thetas, because I know the tan theta value. So that will avoid me doing all this Pythagoras. So what do you think you need to do magic over here to convert all of this into tan theta? And that is your trick. Sine theta by cos theta is tan theta. So what if you divided the numerator and denominator by cos theta? So please try this out. So we are dividing each of the terms, because when you divide the whole numerator, you're dividing each of the terms like this and then like this. Sine theta by cos theta minus 2 cos theta by cos theta. All of you are seeing this? Now what is the nice thing here? I divided the numerator and denominator both by cos theta. Cos theta gets cancelled. And what is this sine theta by cos theta? This part. This is nothing but your tan theta. So what remains of this fraction is what? We finally get this fraction becomes 3 tan theta plus 2 divided by 3 tan theta minus 2. That's it. Now all you have to do is you just substitute. In fact, 3 tan theta is given to you. You don't have to look at tan theta also. You just put it as 4. So let's just plug it in. So if you plug it in, we get 4 plus 2 divided by 4 minus 2, which is basically 6 by 2. The answer is 3. So wasn't that Harry Potter trigonometry magic? Where we took advantage of this relation, not just the ratios, that sine theta by cos theta is tan theta, we divided by cos theta. So the whole trick was dividing numerator, divide numerator and denominator by cos theta. That's all. And when you divide numerator and denominator by cos theta, you have to divide each of the terms, right? Cos theta gets cancelled. Here you get 3 tan theta, 3 tan theta, 3 tan theta is 4. Substitute, done. So there you saw the trick, dividing numerator and denominator by cos theta. The solution became so easy, where we didn't even have to evaluate sine theta and cos theta. Here the question wasn't find all the trigonometric ratios. It says find this. We are lazy and smart people. We want shortcuts. Why should I find sine theta and cos theta when I can get rid of them? You can see cos theta cancels here. And this part is nothing but tan theta. Done. A great question. Should the final answer have any unit? So trigonometric ratios don't have any units because they are ratios of lengths perpendicular by hypotenuse. So if one is in centimeter, the other is also in centimeter. That's why in trigonometric ratios, the final ratio doesn't have any unit here. Same way here, there is no unit involved. So in these questions, you will not see units. The length you might see like 3 centimeter, 4 centimeter, but the ratio finally centimeter cancels out. So here's one more question where you have been given triangle ABC, angle B is given to you as 90 degree. And always mark everything in the diagram. What else has been given? AB. AB here is 7 centimeter. AC minus BC is 1 centimeter. We need to find sine A, cos A, sine C, cos C, all these things are given. So how do you do that? The problem is you don't know the other two sides, you know only the difference, that AC minus BC. Obviously AC is bigger, right? It's the hypotenuse. So what do I do here? So one smart trick you can do is, since AC minus BC is given, you can say let BC equal to x centimeter. So AC will be BC plus 1. So AC becomes x plus 1 because AC minus BC is 1. Can you see? If you substitute this as 1, that becomes x plus 1. So if BC is x centimeters here, this is x plus 1. Now how do I find these ratios? So that means I need to really find all the sides. How do we do it? Again, Mr. Pythagoras comes to our rescue. So what will be the equation? That the hypotenuse square x plus 1 whole square equals x square plus 7 square. Now here you use your algebra. X square, x plus 1 whole square is x square plus 2x plus 1. And this is x square plus 49. X square gets cancelled. So finally we get 2x is 49 minus 1, 48. X is 24. So what are our sides? 7, 24 and 25. And you can check they will satisfy the Pythagoras theorem. Here we used Pythagoras theorem. Please check it. Yeah, these are the Pythagorean triplets, right? And so the whole trick was that you got, since you didn't know the sides, you knew the difference. So the whole trick in maths is doing algebra, x and x plus 1. So when we are looking for sine A and cos A, please remember to carefully look at the angle. So for sine A and cos A, this is the angle A. That means for me, for A, this is the perpendicular. This is the base containing 90 and the angle. And this is the hypotenuse. Is that clear? So if you calculate for A, it will be sine A will be perpendicular by hypotenuse, which is what? X by x plus 1. So that will be 24 by 25. Cos A will be, what is cos A? Base by hypotenuse, which is going to be, what is the base here? Base is 7 divided by hypotenuse is 24 plus 1, 25. That's the answer. But what about sine C and cos C? Can you guys find it for me? Will it be same as sine A and cos A? So when you're looking at angle C, be very careful. For angle C, this is the base. This is, hypotenuse is the same. And this is the perpendicular. Okay. So when you do sine of C, it's going to be 7 by 25. See? 7 by 25. When you do cos of C, base by hypotenuse, x by x plus 1, 24 by 25. So that is why be very careful. This is the angle. If this is C, then this becomes your base, which has angle in 90. Okay. So this was another very important question where we applied Pythagoras theorem and the knowledge of trigonometric ratios. So hope you enjoyed this trigonometric ratios class where we learned about what are trigonometric ratios, how to use them, the relation with Pythagoras theorem, and hope these concepts, these basic important concepts of trigonometric ratios is crystal clear to you now. And do check out the other courses on our website if you haven't done so already, and our Android app, and please do share it out with your friends. Next time we'll again continue some more details about trigonometry. So make sure you revise this. You can watch the other videos as well and go through the topic in your book. Take care and hope you enjoyed this class.